Hello everyone, welcome to my YouTube channel Geography with Sumona. I am Sumona. Today we are going to learn about an interesting topic called inversion of temperature. Normally, as we go higher in the atmosphere, the temperature becomes lower. But sometimes the opposite happens. The air near the ground becomes colder while the air above it becomes warmer. This unusual condition is called temperature inversion. In this video, we will understand what inversion of temperature is, how it happens, its causes, and its effects with simple example. So, let's get started. Before we understand the temperature inversion, we first need to know the normal condition of atmosphere. Normally, when we move higher above sea level, the temperature decreases. This is known as the normal lapse rate. On average, the temperature falls by about 6.5 degrees Celsius for every 1000 meter of height. For example, if the temperature at sea level is 30 degrees centigrade, then at 1 kilometer height, it will be about 23.5 degrees centigrade, and at 2 kilometer it will be around 17 degrees centigrade. Why this has happened? This happens because the earth's surface absorbs heat from the sun and warms the air close to the ground first. As we move upward, the air becomes cooler. In this normal condition, warm air rises and cool air sinks, so the air mixes easily. Now let's understand the exception to this normal rule. Temperature inversion is a condition where the normal decrease of temperature with height is reversed. Instead of becoming cooler with height, the temperature actually increases as we go higher. For example, the temperature at the ground may be 5 degrees centigrade, but at 500 meters, it may become 10 degrees centigrade. This means the cold air stays close to the ground while warmer air remains above it. A simple real life example is a winter morning. You may notice thick fog covering field or road. This happens because cold air gets trapped near the ground and cannot rise due to the warm air above it. This is a common example of temperature inversion. Let's compare the normal condition with temperature inversion. In the normal lapse rate, temperature decreases with height. Warm air is near the ground and vertical air movement is active. Because of this, smoke and pollution rise and spread into the atmosphere. This condition is common during the daytime. On the other hand, during temperature inversion, the temperature increases with height. Cold air stays near the ground and the warm air above acts like a lid, preventing the cold air from rising. As a result, smoke, dust and pollutant become trapped near the surface. This often causes fog and poor air quality, especially during winter nights and early morning. So, the main difference is that in the normal condition, air mixes freely, but during temperature inversion, air movement is restricted. Now, let's understand how temperature inversion is formed. The main reason is a process called terrestrial radiation. During the daytime, the Earth's surface absorbs heat from the sun, but after the sunset, this situation changes. The Earth starts losing the heat back into the atmosphere. This release of heat from the Earth's surface is called terrestrial radiation. Let's understand it step by step. Step 1. At night, the Earth's surface loses heat very quickly through terrestrial radiation. Step 2. At the ground, as the ground becomes colder, it cools the air that is directly touch it. This cold air is heavier, so it stays close to the ground. Step 3. The air higher up does not lose it as quickly. so it remains comparatively warmer. As a result, we get a layer of cold air near the surface and warm air above it. This is called temperature inversion. Let's take a simple example. Imagine you keep a cup of hot tea on a table. After some time, the cup becomes cool because it loses heat to the surrounding air. In a similar way, after sunset, the earth's surface also loses heat and becomes colder. The air touching the ground cools first, while the air above stays warmer. This is the basic process that creates temperature inversion, especially during clear and calm winter night. Now let's discuss the environmental conditions that favor temperature inversion. These are the conditions that makes inversion more likely to occur. First is long winter night. During winter, the nights are longer. This gives the Earth's surface more time to lose heat through terrestrial radiation. As a result, the ground becomes very cold, which cools the air near the surface. Second is dry air. Dry air contains very little water vapor, so it cannot hold much heat. Because of this, the ground cools faster, making temperature inversion more likely. Third is clear sky. Cloud usually acts like a blanket by trapping heat. But when the sky is clear, the Earth's heat escapes easily into space. This causes the ground to cool rapidly. Fourth is calm or light wind. If the wind is strong, it mixes the warm and cold air layers, preventing inversion. But when the wind is calm, very light, the air layers remain separate, allowing inversion to develop. Fifth is high pressure condition. High pressure system creates stable weather. The air slowly sinks and there is very little vertical movement. This helps the cold air stay near the ground. Finally, terrain or surface feature. Valleys and basins are especially favorable for temperature inversion. Cold air is heavier than warm air, so it flows downhill and collects in low-lying areas like valleys. Snow-covered land also cools quickly, increasing the chances of inversion. A simple real-life example is Kashmir or Himachal Pradesh during winter. On clear calm night, cold air settles in the valleys while warmer air stays above. This often leads to fog and temperature inversion. So, to remember easily, the best conditions for temperature inversion are long winter nights, dry air, clear skies, calm wind, high pressure, and valleys or snow-covered surface. Now that we know the condition requirement for inversion, let's move on to the different types of temperature inversion. Now let's learn about the first type of temperature inversion called radiation inversion. This is the most common type of inversion. It usually occurs during clear, calm and dry winter night on flat land. Let's understand the process step by step. First, after sunset, the earth loses heat very quickly. Second, the ground becomes cold. Third, the air touching the ground also becomes cold because it receives less heat from the surface. Fourth, the air above remains warmer because it does not cool as fast. Finally, this creates a layer of cold air near the ground and warm air above it. This is called radiation inversion. A good example is North India during winter. In places like Delhi, Punjab and Haryana, thick fog often forms in the early morning because radiation inversion traps cold air and moisture near the surface. So remember this simple sequence. Ground cools, air near the ground cools, warm air stay above, temperature inversion develop. Second type is called valley inversion. This type mainly occurs in mountain valleys. Cold air is heavier and denser than warm air. During the night, cold air flows down the mountain slope just like water flows downhill. This cold air collects at the bottom of the valley while the hilltops remain comparatively warmer. As a result, the valley becomes colder than the surrounding hills. A real-life example is the Kashmir Valley during winter. Early in the morning, the valley floor is often much colder than the nearby hill station because cold air has settled at the bottom. This is why people living in the valley often experience frost and thick fog on winter morning. The third and fourth type of inversion is subsidence inversion and frontal inversion. Now let's talk about subsidence inversion. This occurs in high pressure areas. Here air slowly sinks from higher levels of the atmosphere. As it sinks, it gets compressed and becomes warmer. However, the air near the ground remains cooler, creating an inversion layer. The fourth type of inversion is frontal inversion. This happens when two different air masses meet. Warm air is lighter, so it moves over the colder and heavier air. The cold air remains close to the ground while the warm air stays above it. These also create temperature inversion. Although these two types are less common than radiation inversion, but they are important in weather studies because they can influence cloud formation, fog, and pollution. Now let's understand one of the most important effects of temperature inversion, that is the smog trap. Normally, warm air rises and carries smoke, dust and other pollutants upward while they spread into the atmosphere. But during temperature inversion, the warm air above acts like a lid or blanket. It prevents the cold air near the ground from rising. As a result, smoke, dust and harmful gases become trapped close to the Earth's surface. These lead to smog, poor visibility and unhealthy air. This trap pollution can cause breathing problems, asthma, eye irritation and other health issues. A good example is Delhi during winter. Every year, temperature inversion traps smoke from vehicles, factories and crop residue burning near the ground. This causes dense smoke and severe air pollution. Another famous example is Los Angeles in the USA, where inversion also trap pollution and create photochemical smog. So, temperature inversion is not just a weather phenomenon, it also has a major impact on air quality, human health and daily life. Now let's look at the natural consequences of temperature inversion. Temperature inversion affects not only the weather but also agriculture and transportation. First is frost formation. During a temperature inversion, the air near the ground becomes extremely cold. Sometimes the temperature falls below 0 degrees centigrade, causing water vapor to freeze on plants and the ground. This is called frost. Frost can damage crops and vegetables. Farmers often face heavy losses because frost can destroy flowers, leaves and young fruits. Second is fog formation. When the cold air near the ground contains moisture, the water vapor condenses into teeny water droplets. These droplets form fog. Fog is very common during winter in Punjab, Haryana, Uttar Pradesh and Delhi because temperature inversion keeps the cold, moist and air trapped near the surface. Third is transportation disruption. Dense fog greatly reduces visibility. This makes driving difficult and increase the risk of road accident. Train services may be delayed and flights are also often postponed or cancelled because pilots cannot see the runway clearly. So, temperature inversion has many real-life impacts. It can damage crops, create thick fog and disturb transportation. Temperature inversion is not always harmful. In hilly regions, it can actually benefit agriculture. Farmer grows food such as apple, grapes, peaches and cherries on hill slope instead of valley bottoms. This is done intentionally to reduce frost damage. For example, imagine a valley shaped like a bowl. Cold air settle at the bottom like water. Hill slopes stay warmer. So apple and grape orchards are planted on slope instead of the valley floor. So The golden rule of temperature inversion is cold below, warm above. This is the easiest way to remember temperature inversion. Normally, temperature decreases with height. The air near the Earth's surface is warmer, while the air above it is cooler. In a temperature inversion, this pattern is reversed. Cold air stays near the ground, warm air remains above it. These warm layers act like a lid or blanket, preventing the cold air from rising and stopping pollutants from dispersing. As a result, fog, frost, and smog can develop near the surface. So, whenever you see cold air below and warm air above, you know that a temperature inversion has formed. Thank you so much for watching this video. If you found this helpful, please like, share and subscribe to my YouTube channel Geography with Sumona for more interesting and educational geography video.